Hey guys, this is Mr. Anziano recording a quick video on 7.1, which you will have in class tomorrow. It's about solving oblique triangles, so ones that are not right triangles. Okay, so we're trying to figure out how we can somehow create relationships that will allow us to solve these triangles when they're not a right triangle. Alright, so the first thing we need to do is, it says using angle C here, find an expression for H in terms of B. Okay, so here's angle C. We want to try and write this side H in terms of B, right? So we notice that H is the side opposite angle C and B is the hypotenuse of that small right triangle. So we're going to create a relationship that looks like the sine of angle C is equal to side H over side B. Okay, so to put that in terms of just H, we need to multiply both sides by B, right? And then we'll get that H is equal to B times the sine of C. Okay, which maybe we don't really know what that does for us yet, but we're going to figure it out. Next it says using angle B, we need to find an expression for H in terms of C. So we're going to do the same thing. We notice that the sine of angle B is equal to side H divided by side C. To get H by itself, we're going to multiply both sides by C. Okay, so H is equal to C sine B. So now that we have H in terms of both B on the left and C on the right, we can do another thing with that, right? So the next paragraph here says, if both of the expressions above are equivalent to H, then what must be concluded about the two expressions themselves? Write this relationship of equality in the space below to derive a relationship that exists between the sine of an angle and the side across from that angle. Okay, well, we know that if H is equal to both B sine C and C sine B, that we can set those things equal to each other, right? So we get that B times the sine of C is equal to C times the sine of B. Now, if we wanted to create a relationship, again, we're trying to figure out, okay, what does this really do for us, right? Well, if I tried to get B away from this side, I would have to divide both sides by B, right? Then if I tried to get C away from this side, I'd have to divide both sides by C. So it kind of works out to look something like that. In other words, we get that the sine of angle C over side little c is equal to the sine of angle B over side little b. Okay, and that right there is the relationship we're looking for. Okay, and that actually is the law of sines. The law of sines tells us that the sine of A over the side opposite A is equal to the sine of B over the side opposite that angle B, which is also equal to the sine of C over the side opposite that little c. Alright, that right there is the law of sines. So what it allows us to do is solve problems like this one, where we are given that we have a triangle ABC where angle B is 130 degrees. Okay, so this angle right here is 130 degrees. You can draw it any way you want. This is just my interpretation of that triangle. Okay, we also know that that right there is angle B, so I'm just going to say that this is A right here and that's C right there. So what else do we know? The side opposite angle C, little c, is going to be 11 centimeters. Okay. We also know that side little b is equal to 15 centimeters. Okay. So we need to figure out all the rest of this triangle. And how do we do that? We're going to use this relationship up here. Alright, so we know that the sine of angle B over the side opposite that angle is going to be equal to, well, we know that this side 11 is given. So we're going to use the sine of angle C over the side opposite that angle. Okay, so really if we replace this relationship with values that we know, we have that the sine of 130 degrees over 15 is equal to the sine of angle C over 11. Now to get sine of angle C by itself, I'm going to multiply both sides by 11. And I would get that the sine of C is equal to 11 sine 130 over 15. And we talked today about using the inverse trig ratios, right? The inverse trig functions. So in order to get rid of sine, I need to take the inverse sine, or the arc sine, of both sides. Okay, so that's where we're going to need a calculator. Alright, so what happens if I take the inverse sine of 11 sine 130 divided by 15. It's kind of a lot to punch in your calculator, but if you punch it in correctly, you should get that angle C. Right? Angle C is equal to 34.178 degrees. 34.178 degrees. Okay, that's nice. That's the first piece of the missing sides and angles of our triangle. Alright, so we can also, if we want to, go ahead and put that right there, 34.178 degrees. Alright, that allows me to build on this triangle a little bit, because now I can just find this missing angle, knowing that all of the three angles in this triangle have to add up to 180. So, next thing I'm going to do is add 130 and 34.178. Okay, and that's going to be equal to 164.178. I can do that without a calculator, right? And then I'm going to take that and subtract it from 180. And what do we get? 180 minus 164.178 is 15.822. So that angle right there is going to be 15.822 degrees. Alright, and that allows us to find this one last missing side, because now that we have the angle opposite side little a, I can use another law of sines ratio and figure out what that missing side length is going to be equal to. So I know that sine of b over side little b is going to be equal to the sine of a over side little a. I have the b values and I have the angle a, so I'm just going to use b equal to 130, right? So the sine of 130 degrees divided by 15 is going to be equal to the sine of 15.822 degrees divided by that missing side a. So now that I want to find a, I need to multiply a to both sides, right? And this is going to get a little tricky, but I get a times the sine of 130 over 15 is equal to the sine of 15.822 degrees. Okay, and then to get a by itself, we're going to divide both sides by the sine of 130 over 15. So that looks like the sine of 15.822 degrees over the sine of 130 over 15. And what do we get? Let's see what our calculator tells us here. We're going to get the sine of 15.822 divided by parentheses the sine of 130, close those parentheses, divide that by 15, and then close off those parentheses. Notice how I have one thing divided by this fraction where that entire expression is closed off in its own set of parentheses, right? And let's see what we get. We get that a is equal to 5.339. A is equal to 5.339. And there it is. So we have side A, we have angle C, we have angle A, we have angle B, we have side B, and we have side C. So that right there is all 6 missing sides, right? We started with 3 things, and we found 3 things. So just to be sure about this, let's label all the pieces that we don't have. Okay, we have that angle, and that angle. We have that side, and next we just need to put 5.339 right there. So this triangle was drawn a little bit off scale, because really this side looks like the smaller one, and we only got 5.339 there, but that'll happen, and it's not too big a deal. Alright, and there you have it. I will record the next video momentarily. Thanks, guys.